Have you been asked to solve a system of equations using substitution and you're not sure what to do? Well, you've come to the right place because I'm Professor Capko and I'm going to show you how to easily solve this particular system of equations and know the strategy for solving others. But first, I want to say I believe something great is going to happen for you today. And now back to the video. If you're someone who finds math hard and you think you're not able to do math, give this video a thumbs up. That way I'll know that there's more of you out there that could use additional videos such as this one. Thank you. All right, this is a system of equations. All a system of equations means that there is more than one equation and they work together as a system. So we've got equation number 1 here and equation number 2 here. You don't have to number them, and I could have numbered this one number 1 and this one number 2. I'm just doing this to separate so you can see this is an equation and this is an equation. And what each of these are generating is a line on a graph. It's a line on a graph. So this is line number 1 and this is line number 2. I could draw them both on the graph, maybe using 2 different colors of ink, something like that. But what we're seeking, and these are 2 straight lines because there's no exponents involved. So they're going to be 2 straight lines on the graph. And we're seeking where these 2 lines cross. So in other words, where does line 1 cross line 2? They're either going to cross one time or they're going to cross infinite times. In other words, they're the same line, they're on top of each other. Or the third option is they never cross at all. If they never cross at all, that simply means line 1 and line 2 are parallel, like railroad tracks. We are looking for the x and y coordinates where line number 1 and line number 2 cross. And in this particular case, we're asked to use the substitution method. There is more than one way to find this answer, but in this case, we need to use the substitution method. All we want to do is solve for one of the variables, either the x or the y, and then once we have solved for one of the variables, and we can do that either in equation 1 or equation 2, and once we have solved for one of the variables, then we take that and we plug it into the other equation. So I'm going to demonstrate that to you here. Again, we can start with equation 1 or equation 2, and we can do either x or y. It doesn't matter. It should all get us to the same place. But in this case, I'm just going to choose. If one seems obviously easy, I would choose the easy one. These both seem fairly straightforward. So I'm going to start with equation number 1. I'm going to rewrite it down here. 4x minus 3y is equal to 6. And that's equation 1. I just copied it back down. And what I'm going to do is I'm going to solve for the x. So I need to move everything away from this x to the other side of the equation. Let's start with the minus 3y. I just do the opposite. Since I'm subtracting 3y, I'm going to add 3y to both sides. On a line, I bring down my 4x. Haven't done anything to that, just bring it down. Negative 3y plus 3y, this makes it a 0. I don't need to write that. I bring down my equal sign. And then I've got 3y and I've got a 6 here. I can't combine them because this one doesn't have a y. So I'm just going to bring it down and write it this way. 3y plus 6, because it's a positive 6, and I've got a positive 3y. So I just write 3y plus 6. So far, so good. Next step, I want to get the x by itself, and the relationship between the 4 and the x is multiplication because they're right next to each other. There's no plus or minus between them. So I'm going to do the opposite of multiplication, and that would be division. So I'm going to divide that side by 4. And if I divide that side by 4, I've got to do the exact same thing to the other side. So I divide both sides by 4. 4 over 4 is 1. So I cross that out, and I'm left with x here. Bring down my equal sign. And I'm going to just copy this one down, 3y plus 6 all over 4. There doesn't seem to be anything that I can easily simplify on this, so I'm going to leave it. I'm going to leave it. So I have an x that's equal to 3y plus 6 over 4. It's a little messy, I agree, but that is what the x works out to be when I'm solving for x on equation 1. So now I'm going to copy down equation number 2, which is 5x plus 2y equals 19. And I've copied down equation 2. Now I want to take my x from equation 1, which is right here, and I'm going to plug it back in to equation 2. Let me do that for you so you can see what I'm talking about. Again, the 5 is right next to the x, so that means it's multiplying. So I'm going to write 5. I'm going to multiply it by, and I'm going to pull the x out and just put an empty box here. I'm going to label it x, so I know what goes in there. I'm going to add 2y, just copy that down, equals 19. Everything else I just copied down. I just pulled out the x. Everything else I just copied down. What do I want to put in the x box? Well, I want to put what this x is equal to, right? This and this are equal. We know that because that's what we worked out. So I can now plug that in over here. 3y plus 6 all over 4. So it looks messy, but I've plugged in the x into the x box, and lo and behold, there are no more x's here. The x's are all gone. Let's keep working this problem. We can now solve for y. So let's go ahead and do our multiplication. This is, I'm going to distribute. So it's 5, and I have to multiply it by everything on top here, 3y plus 6, and all over 4. I can just rewrite it that way. Plus 2y is equal to 19. I can just rewrite it that way. I have to distribute this by multiplying by each of those terms. So 5 times 3y is 15y, and 5 times 6 is 30, so it's plus 30, and that's all over 4. I bring down the plus 2y and equals 19. So far, so good. Next, I would like to get rid of this 4 down here. I could find a common denominator, but let's just get rid of the 4. It's in the denominator, and we do that by multiplying both sides by 4. So I'm going to multiply both sides by 4. If I multiply this, so I can rewrite this as 4 times 15y plus 30 all over 4 plus 4 times 2y is equal to 19 times 4. All I did was I broke these two up, and I'm distributing the 4 to here and to here. If I'm multiplying 4 times this, and there's a 4 in the denominator, I can cross out the 4's because this cancels that one out. And I'm left with 15y plus 30 and 4 times 2y is 8y. And I'll multiply the 4 times 19. 4 times 19 is 76. All right, so now let's get our y's together. I have a 15y and an 8y. 15y plus 8y is 23y. So I combine this and this, plus 30 is equal to 76. Now I want to get this 30 out of here, so I'm going to subtract 30 from both sides. 76 minus 30 is 46. So I've got 23y is equal to 46, running out of room here. And you can see if I divide, now I want to get the y by itself. So if I divide both sides by 23, 23 over 23 cancels out, so my y, 46 divided by 23 is 2. So my y is 2. So I'm going to go up here, and I'm going to write that down up here. 2. My y is 2. I still have to find my x. How do I do that? How would I find my x? Well, very simply, I'm going to take my y that I found, the 2, and I'm going to plug it back into one of the equations. In this case, I'm going to plug it back into equation 1. Since we did all this work with equation 2, let's plug it back into equation 1. So I'm going to recopy down equation 1. That's 4x minus 3y is equal to 6. And I can now plug in the 2 for the y. So I've got 4x minus 3 times y is equal to 6. I'm going to plug the 2 right into there. That's the y box. So I've got 4x minus 3 times 2 is 6 equals 6. And then I need to get this by itself, so I'm going to do the opposite. I'm subtracting 6. I'm going to add 6 to both sides. So I'm left with 4x, just copy that down, negative 6 plus 6 is 0. Bring down my equal sign. 6 plus 6 is 12. Now I'm going to get this 4 out of here because I want the x by itself. The relationship is multiplication. I do the opposite. I divide. If I divide one side by 4, I divide the other side by 4. The 4 over 4 becomes a 1. So I'm left with an x is equal to 12 divided by 4 is 3. My x is 3. And I put that in there, and that's the solution to this system of equations using substitution. In other words, equation number 1, line 1, and line 2 cross each other at x is 3 and y is 2. You can check this by plugging these back into each of these and make sure they work. I'm not going to do that right now, but you can do that anytime you do your work. Double check by plugging it back in. Good. So now you know how to solve a system of equations using substitution. There's a lot more that you are going to need to know for algebra. So go ahead and subscribe to my channel and click that notification bell so you never miss a video. Thank you.